Okay, in this video, we're going to look at right triangle trig or right triangle trigonometry. The first thing we need to do is to define the nomenclature of the sides in a right triangle. So you can see in the following right triangle, we have a given angle theta. This is one of the acute angles in our right triangle. And the sides of this triangle are labeled as follow. The side across for our angle of interest, which is theta in this case, is going to be referred to as the opposite side. Opposite the angle is opposite. The side across from our right angle is the hypotenuse. And the side adjacent to our angle of interest theta, that is not the hypotenuse, is going to be the adjacent side. So that is how you define the sides in a right triangle for trig: opposite, adjacent, and hypotenuse. If you change the angle that you're using, your acute angle, your nomenclature for both opposite and adjacent are going to change. So for example, let's say we're looking at this angle and we're interested in angle X. The hypotenuse will not change. That will always be referred to as hypotenuse. That's always the angle across from 90 degrees. But now the side that's across from our angle of interest, since we're interested in X now and no longer theta, that's going to be that side down here in our triangle. So now this will be referred to as our opposite side. And the side adjacent to our angle, the angle of interest, that's going to be our adjacent side. Okay, so it's important to realize that while the hypotenuse will always be the same for a right triangle, regardless of which acute angle you're interested in, the opposite and adjacent side will change depending on which acute angle you're looking at. Okay, so right triangle trig is basically just dealing with the relationship between sides, the ratios of sides, and the angles in a right triangle. I want to look quickly at what that ratio looks like. So if we look at the following GeoGebra activity, we have a right triangle with an angle of 28 degrees. This is the ratio of the opposite side. The opposite side is, again, the side opposite our angle. So in this case, it's 5.21. And the adjacent side is the side next to our angle that is not the hypotenuse. So this side would be our hypotenuse, and this is our adjacent side. So I can see for this angle of 28, if I change the side of my triangle, but my angles stay constant, so I'm not changing my angle of 28, my sides are getting smaller, but if you notice, as I change it up here on the right, my ratio of sides is not changing. So my sides are getting smaller, but when I divide those two sides, opposite divided by adjacent, that ratio remains constant. Okay? The same thing is true if I look at the adjacent side divided by the hypotenuse. I look at that ratio. Again, I change the side lengths, but my ratio remains constant. Again, that's for a constant angle. My angle is not changing, and neither is the ratio of my sides when I take the adjacent divided by hypotenuse. And then finally, the same thing is true for opposite divided by hypotenuse. So why this is important is that is the basis of what we get trig from. So a long time ago, some mathematicians decided, okay, let's call those ratios sine, cosine, and tangent. So for the angle, acute angle theta, in this case theta is shown here, the ratio of the opposite side divided by the hypotenuse side, we're going to call that sine. For our angle theta, again here, our opposite, adjacent, and hypotenuse side, we're going to call the ratio of the adjacent side divided by the hypotenuse, we're going to call that cosine. And then finally, tangent is defined as the ratio of our opposite side divided by our adjacent side. There is a very helpful acronym that is referred to as SOHCAHTOA that can help us remember these trig ratios. So the acronym comes from the definition of the trig ratios themselves. So refers to sine. Sine is opposite over hypotenuse. That's where we get so from. Cosine, adjacent over hypotenuse. There's our ca. And then finally, tangent is opposite over adjacent. and that's our TOA. So these are the trig ratios for sine, cosine, and tangent of a given angle. And it has to be a right triangle. So let's use those definitions to calculate missing sides in a triangle. So we're given the following triangle, and we're given the angle 28 degrees. We want to calculate the sides x and y. Well, I know from SOHCAHTOA that my sine is going to be opposite divided by hypotenuse. Cosine is going to be adjacent divided by hypotenuse. And then finally, tangent is going to be opposite divided by adjacent. So in this case, my x side is across from my angle of interest, across from 28 degrees. So that will be my opposite side. The side next to or adjacent 28 degrees is my adjacent side. And the side across from my 90-degree angle is always my hypotenuse. If I want to solve for x, I see that I have opposite and I was given hypotenuse. So which one of my trig functions can I use that has the ratio with opposite and hypotenuse? Well, I go over here and I see I can use my sine function. So I take the sine of 28 degrees, and I know, again, sine is opposite over hypotenuse. So I'm going to get opposite is x in this case, and my hypotenuse is 19. So I take the ratio of x divided by 19. I'm going to multiply both sides by 19 to solve for x. I'm going to put x on this side first, and I get x equals 19 times sine of 28. So if you have a graphing calculator, you can calculate the sine of 28. This is, I'm using a TI-84. I have to refresh it quickly, so bear with me while I do that. But you can also use Desmos. You can go to desmos.com and use the graphing calculator function on Desmos. So I want to plug in my value, 19 times sine of 28. The first thing you always have to do on any graphing calculator, Desmos included, is make sure that you are in degree mode. You do that by going to the mode function. You click on mode, you scroll down, and you're going to go over to degree, highlight degree, press enter, and now you're in degree mode. So you can get that. So let's enter this and find out what the length is of our side. So we're going to take 19 and we're going to multiply that by sine. We go up here and we click on our sine function. Sine of our angle 28. So we're going to enter 28 and we press enter. So our x side is 8.92. So let me write that down. X equals 8.92. All right, let's do the same thing for my y. Calculate my y side. So again, I know y is adjacent and I was giving hypotenuse. So which trig function has adjacent and hypotenuse? I know adjacent and hypotenuse is my co function or cosine. So in this case, I'm going to use cosine. So cosine of 20, oops. I put an 8 there, sorry about that. Cosine of 28 degrees. I'm saying 28 and writing cosine at the same time. Cosine of 28 degrees equals adjacent over hypotenuse. My adjacent side is y and my hypotenuse is 19. So let's multiply both sides by 19 to solve for y. And we get y equals 19 times cosine of 28 degrees. Again, I'm going to pull up my graphing calculator and I'm going to calculate that. So I'm going to enter 19 and I'm going to multiply that by cosine. So I type cosine of my angle 28 and I press enter. and I get 16.77. So my y side is equal to 16.78 if I round. So y equals 16.78. Okay, so those are the two sides of my right triangle, the two legs of my right triangle. Since this is a right triangle, we can also use Pythagorean theorem to calculate the sides. So I know that the ratio or relationship using Pythagorean theorem is x squared plus y squared is going to equal 19 squared. So in this case, I'm going to have 8.92 squared plus 16.78 squared should equal 19 squared. So let's go ahead and check that on our calculator. So I type in 8.92 and I square that. And I add 16, sorry if you can hear my dog barking, 0.78 squared. And I press enter. So I get 361. I know that that's going to equal 19 squared. So if I take the square root of that, I should get 19. So let me do second function. Oh, second function square root. And I'm going to go up and grab my value and enter. And I do indeed get 19. So these are the correct sides of the triangle that we solved using trig functions. Okay, let's do another example here quickly. 42 degrees. First thing I'm going to do is label my sides. This is opposite. This is adjacent. And across from my 90 degree is always my hypotenuse. So let's use trig functions to solve x and y. Let's solve x first. Again, I have opposite and I'm given adjacent. Which one of my trig functions, when I look at SOHCAHTOA, uses adjacent and opposite? Well, that would be my tangent function. I know tangent of my angle, theta, is opposite over adjacent. So my angle in this case is 42 degrees, and I know that's going to equal opposite is x divided by my adjacent side of 32. So let's multiply both sides by 32, and we get x equals 32 times the tangent of 42. Let me pull up my graphing calculator again. Move that over here. And I'm going to get 32 times the tangent. I press tangent and I enter my angle 42 and enter. And I get 28.81. So my side x equals 28.81. Okay, let's use trig to solve for my side y, my other side. So y is the hypotenuse, and let's choose what we were given, the adjacent side. So what trig function uses adjacent and hypotenuse? Well, that would be my cosine or ca function. Cosine of my angle equals the adjacent side divided by the hypotenuse. Again, that's ca from SOHCAHTOA. So let's substitute in those values. So I'm going to take cosine of 42 equals adjacent side is 32. I'm going to divide that by my hypotenuse of y. So if I multiply both sides of my equation by y, I get y times cosine of 42 equals 32. Let's divide both sides by cosine of 42. And I'm left with y equals 32 divided by cosine of 42. So again, I'm going to plug that into my graphing calculator. I have 32 divided by, I go up to my trig functions, cosine of my angle 42, and enter, and I get 43.06. Y equals 43.06. So those are the two sides of my triangles solved using trig functions. We can also use trig to find missing angles. This is referred to as using inverse trig functions because we're looking for our angles. Angles are always going to use inverse trig functions. So let's just go over this first by showing an example. I have a right triangle. I'm going to label my sides. This is my opposite side, opposite my angle of interest. This across from my 90 degrees is my hypotenuse. And the side adjacent to my angle of interest that is not my hypotenuse is going to be my adjacent side. Okay, so I am given the hypotenuse and I'm given the opposite. So if I go back and I think of my SOHCAHTOA, which trig function deals with the ratio of opposite and hypotenuse? Again, that's sine. So I know that sine of my angle x is going to equal the side opposite that angle, which in this case is 15, divided by the side that is the hypotenuse, which is 24. Because sine equals opposite over hypotenuse. Okay, now in order to get my angle from this equation, we need to use what is referred to as inverse trig functions. So inverse trig functions are written as sine inverse of our angle x, okay? So I'm going to take the inverse function of both sides of this equation, and I take the inverse trig function of sine of x and the inverse function of 15 divided by 24. When you take the inverse of a sine function, these two will cancel each other out and you'll simply be left with the angle. So the angle x equals the inverse. That means I'm backing out the angle from this ratio of 15 over 24. So we can do that again on our graphing calculator. So I want to go to inverse sine. So I press second function, the blue button here, and my sine. And you can see inverse sine pops up. I'm going to enter my ratio in there, 15 divided by 24. And I press enter. And I get my angle, which is 38.68. So I'm going to enter that down here. My angle x is, I already forgot, 38.68. Yes, 38.68. 38.68 degrees. So that is how you use inverse trig to get an angle. So let's do the same thing over here. My angle of interest that I'm looking for is here, x. So what they give me is the adjacent side and the hypotenuse. So which one of my trig functions, SOHCAHTOA, deals with the ratio of adjacent and hypotenuse? Well, that would be my CA, or cosine function. So cosine of x is going to be the adjacent divided by hypotenuse. Again, that's from CA, adjacent divided by hypotenuse. So let's go ahead and substitute that in. So I have cosine of x equals adjacent, in this case is 8, divided by my hypotenuse, which is 11. So whenever you're looking for angles, you're always going to use your inverse trig functions. So I'm going to use inverse of cosine of x. And I'm going to do the inverse cosine of both sides of the equation, because whatever you do to one side, you have to do to the other side. Even with trig, this is going to give me my angle x. And then I need to plug this cosine inverse of 8 divided by 11 into my calculator. So again, I go to second function and cosine, and I enter my ratio, 8 divided by 11. And I press enter. Oops, pressed it twice. And I get my angle, 43.34. So my angle in this case is 43.34. So that is how you use inverse trig to solve and find missing angles. I hope this video helps. Thanks.